Okay. The first lesson is on computing numbers. Okay. Computing numbers, well, there are lots of tricks here. First we have to know the notation about, we remember we have, for numbers, there are many ways to denote a number, right? And so, yeah, let me begin with the phone. Okay. So in mathematics, we have the following notation like a 2.3 bar. Okay. What does that mean? That means it's 2.33333. Now, by definition, rational number is a number if it's in the decimal form, either has a finite many digits or have a repeating digits. Okay, the digits can be repeated, you know, maybe 3 digits repeated, maybe 5 digits repeated. But here it's yeah, it's just 0, you know, 3 bar. Okay, it's a 3. Okay. And conversely, every fractions also, if in the decimal form, must be in one of this form. Either has a finite many digits after the decimal point, or you have repeating digits. Okay. Now, those are called rational numbers. Okay, rational numbers, by definition, the rational numbers will be m over n, where m and I integers. Okay. Irrational numbers, right? Irrational numbers are numbers which are not the rational numbers. Okay, those are the numbers not rational. Very simple. Okay. But it's not easy to prove. For example, like a square root 2, square root 3, square root 5, and so on. Pi. Maybe you also heard about e. Those are irrational numbers. Okay. And you can modify irrational number now. Irrational number could be something like that. Every number, you know, irrational number could be like a square root 2 minus 1 over square root 2 plus 1. This is the irrational number. Okay. But it's a fraction of 2 irrational numbers. Now you can modify it to change the form. Okay. For example, this is going to be square root 2 plus 1 multiplied square root 2 minus 1. Here's square root 2 minus 1 and times square root 2 minus 1. Okay. Then the denominator, when you multiply this out, it will be square root 2 squared minus 1 squared. The numerator is just square root 2 minus 1 squared, right? So you can multiply this 2 minus 1. Here, square root 2 squared is 2 minus 2 square root 2 plus 1 squared. So you will get, actually, the denominator is 1, the numerator is 3 minus 2 square root 2. You see, you can change it to this form. Okay. And you can also express 0.5 bar plus 0.21 as a common fraction. Okay. How to do that? First of all, you have to convert it to a fraction, common fraction, right? 0.5 is going to be 5 over 9. And this 0.21 bar is 21 and over 99. Okay? If you know that, and then you can combine them, right? So what you do is you multiply by it over here, make a common denominator. Okay? And then 55 plus 21, 76, and 99. Okay. Now, you have to prove that the y, the questions, now this is a question, right? y 0.5 is going to be 5 over 9. Nobody's thought about it, right? We can prove that. So 0.9 bar is actually what? It's 9 over 9. The proof involves the geometric sequences, which we're going to study later. Okay, so we're not going to prove that. But if you have some idea why this two equal, then let me know. In I already mentioned square root 2, right? What does a square root 2 mean? The rational number, right? Square root 2 is also denoted by 2 to the 1/2. This will be the number whose square is going to be 2. That is a positive number. Okay? So we can also introduce the nth root of a number. A positive number, okay? The nth root of a positive number, okay, is defined to be the number which is denoted by this. This is going to be the number. There's only one number such that its n square is going to be n. Yeah, the nth power is going to be n. So there's only one number with this property. So what is square nth root of a? You just say that this is a number whose nth power equals 8. Right? And so we other notations for this one is also denoted by 8 to the power 1 of n. Okay? Yeah. So so 8 to the 1 over n is the number, is the nth root of a, in other words. So for a rational number, okay, can we talk about m of a to the n over n? This is defined to be this, okay? So the nth root of a then to the nth power. Okay? In other words, like a 2, 8, okay, it is going to be 2 over 3. Eight to the 2 over 3 is going to be 8 to the 1/3. Is in other words the third root of 8. So third root of 8 is going to be 2. Okay, that's a 4. You know the third root of 8 and 2 cubed is going to be 8. Okay, that's what 2 is going to be 1/3 of it. 8 to the 1/3. Okay. 8 to the 1/3 is a number whose cube is going to be 2. It's going to be 8, sorry. So I know 2 cubed is, the cube of 2 is going to be 8, so that must be 2. Well, we have a formulas. We have some formulas we should know. A to the alpha, a to the beta, multiply them out is a to the alpha plus beta. Okay. We also a to the alpha divided by a to the beta. It's going to be a to the alpha minus beta. And we also have a notation a to the negative alpha is going to be 1 over a to the alpha. Another formula will be a to the alpha and to the beta is going to be a to the alpha beta. And what else? Oh, we have a b to the alpha. It's a to the alpha, b to the alpha. Another one is a over b to the alpha. It's a to the alpha, b to the alpha. Okay, so those are the formulas. We should be familiar with that. Okay, so let us square 8. Okay, take a look at square root. Square root, of course, is viewed as 8 to the 1/2, right? And the 8 is going to be 2 times 4 to the 1/2. Okay, so by above formula, by this formula, right, it's going to be 2 to the 1/2, the 4 to the 1/2. But 4 to the 1/2 is going to be 2, because that's square root of 4, right? So it's 2 to the 1/2 times 2. So we also tradition writing this form. Okay. Similarly, you can express square root of 12. And like a square root of 3 times 4, that's a square root of 3, square root of 4. And square root of 4 is 2, so square root of 3 times 2, that's 2 square root of 3. Okay, so let's take a look at the next problem. This is a math concept problem. 4 to the 11, 4 to the 11 plus 4 to the 11 plus 4 to the 11, you have 4 here. And then to the, and let's simplify. So any idea? Okay, so how many 4 to the 11? 1, 2, 3, 4. So it's actually 4 times 4 to the 11, right? Then combine those two terms in the inside. That's 1 plus 11 is 12. Right? So now this is actually 4 to the 12 over 4, and 12 over 4 is 3. So the answer is 4 cubed. Right? Yeah, good job. Next one. All right, so let's simplify the next one. 2 to the 2020 minus 2 to the 2018 divided by the 2019. Can you simplify it? All right, so 2 to 2020 is a very large number, right? But we can simplify it. You can, the difference is, you can, 2 to 2020 is 2018 plus 2. So 2018 and times 2 squared minus 2018. Right? So you can take 2 to the 18, but then 2 squared minus 1 would be, right? It would be 3. Okay. Then you take the the formula we're going to using is this formula: a to the alpha over a to the beta is going to a to the alpha minus beta. So 2018 minus 2019, and here's just 3. 2018 minus 2019 is going to 2 to the negative 1, right? So it's 2 to the negative 1 is just the 1/2, so it's 3 over 2. Okay, so you can simplify to 3 over 2. All right, so let's take a look at the next problem. Okay, what is the best way? Don't use calculator. Yeah, can you simplify this without using calculator? The basic formula we need to know is a squared minus b squared is going to be a minus b, a plus b. Okay. So the above one is 235 minus, let's give it 235 minus 1. It's 235 plus 1, right? 236. Then you use the above formula. And this will be 235 squared minus 1 squared. Then clearly 235 squared is gone. So it's 235, it's 1, then 235. Okay. Recall some formulas for fractions, right? If you add two fractions or together, you get common denominator BD, and then AD plus minus BC. Okay. Now, if you multiply this out, you just numerator times numerator, denominator times denominator. But it's divided by CD, then you have to turn this upside down, DC. Then it'll be AD and BC. Okay. Sometimes you write it like this. A fraction over another fraction. All right. So let's take a look at the following problem, then ask you to do this another way. So simplify 1 over 1 minus 1 over 1 minus 2. Okay. Now, step by step, right? 1 minus 1 half is 1 half, but the 1 divided by 1 half, that's going to be 2. So it's negative 1. Okay. So I'm going to ask you to do the following. Okay, please do it. And post the answer. Okay. Anyone get answers? Alex, now, what do you got? Okay. So this is going to be, right, simplify this, and here 2 plus 1/3, 7 over 3. Then turn this upside down, 3 over 7, and add them together will be 10 over 7, that'll be 7 over 10. Okay. However, this probably nobody can do that. Okay. I have an infinite many. It's taking forever. So no matter how because you zoom in, you will see the same pattern. Right? What is that? What is that number? Right? Chain reaction. Right? What is this number? Right? How do you solve that? Well, anyway, this number is smaller than 1, clear, right? Smaller than 1 because the denominator is 1 plus. Okay? And let's compare this part. This part is identical with the whole larger part, right? It's copy, right? So if you let x be that, x will be 1 over 1 plus x, right? Then you can solve it. Okay. So how to do that? Well, how do you solve this equation? You let x to be this whole fraction. Then the part I circled actually is also the whole fraction. They're identical, same. Right? So that x should be equal to 1 over 1 plus x. Then you simplify it. And how do we solve this equation? It's a quadratic equation, right? X squared plus x minus 1 equals 0. X is going to be negative. We put negative 1 plus minus 1 squared minus 4ac. So I get negative 1 plus square 5 divided by 2. Right? It's a plus minus. It's quadratic formula you studied, right? And since x is positive, so x must be this one. This is a positive one. And actually, can you see that this is a less than 1? Can you see that? Question. Without using calculator. X is greater than 0, less than 1, y. Okay, then you estimate the square of 5, right? So let's check. It's a square of 5 minus 1 over 2. I'm going to I think it's smaller than 1. How do you see that? Well, do you agree with that, right? Square of 5 is less than square of 9. Everybody knows that. So it's going to be square of 9 is 3 minus 2, so it's 1. So indeed, x is less than 9. Okay? Yeah, this is the best way to check. All right. Have you heard about n factorial? N factorial is 1 times 2 times 3 all the way to n. Okay? But n factorial is quite special, right? It's 8 factorial when see 1 times 2 times 3, 4, 5, 6, 7, 8. I can stop anywhere here. This is 4 factorial. Okay? So when you simplify like 8 factorial, 4 factorial, first of all, you should write 8 factorial is 4 factorial and 5, 6, 7, 8 divided by 4 factorial. So this cancels out. Okay. Right. So I'm going to ask you to simplify. 9 factorial minus 8 factorial. 9 factorial plus 8 factorial. Okay, can you do this? Right, so you cannot multiply this out, but what you can do is 9 factorial can written as 8 factorial times 9. Okay, the new and denominator have the common factor, which is 8 factorial. So you can take 8 factorial. You don't need to know the exact value of 8 factorial. Okay. Okay, so 8 factorial, you don't need calculate. It's gone. So it's 9 over 10, which is 4, 5. Okay. Oh, by the way, there's a relative problem. How many zeros are at the end of, right, end of 26 factorial? Anyone has an idea? So 26 factorial is 1 times 2 times 3, 5, right? And then 6, 10, 15, 20, 25, 26. So in order to get 0 at the end, the key point is 2 times 5 is going to be 10. And whenever 2 and 5 meet, then you just produce 10. You get addition 0 at the end. Okay, so how many, we have a pent of 2z, right? But we do not have enough 5. But be careful, 25 contains 2 factors of 5. Okay, so you have 26 is going to be have a 5 to the power 1, 2, 3, 4, 5, 6 times something, and 2 to the some power p. And this p is definitely greater than 6. So there'll be enough to there to do multiplication with 5. So you get enough 0 at the end. You get 6 0. Right. Good job. All right. We have a following expression. Combine them into one. So let's see what do we get. Common denominator n plus p minus n. All right, so n canceled out. So only p n here, n plus p. And so this is a very important identity. But you can also divide both sides by p. So you can express in this form. Right, so now 23 times 24 is going to be, since difference is 1, so it's going to be 23 minus 24. Okay, so that can be decomposed. It's useful. Okay, let's look at this following problem. Simplify. Okay. 2000 times 2001 2001 times 2002 and 2019 times 2020. So how do you solve this problem? How do you simplify it? Right? And then how many terms there? There are more. There are more than, I think that's about 20 terms here. 20 terms. You cannot do them together quickly, right? But there's a trick here. These two consecutive numbers can be separate. It's going to be 2000 minus 1 over 2001. And here 2001 minus 2002. And so on, 2019 minus 2020. Then you will see that all the terms cancel out. So you get 2000 minus 2020. Okay. All right, here's a trick, okay? I'm going to ask you to compute, simplify 3 times 5, 5 times 7, 7 times 9. Can you do that? Let me double check, okay, my problems. 7 times 9, 5 times, sorry, I'm copying it. 7 times 9, here's 99 times 1 here. Otherwise, you cannot solve it. Then you leave. Work on this. Okay, so you still have to decompose the number into two different terms. There's a difference, right? Then you can cancel a lot of terms. Right? Otherwise, you know, how many terms here? We have a lot of terms, right? 3 from 3 to 9. Three to 99, right? There are lots of terms. So the idea is this should be equal to 1/3 minus 1/5. But 1/3 and 1/5, it's 2 and 5 is not the consecutive numbers. The consecutive other numbers. So the difference is 2. So when you combine those two terms, it will be 5 minus 3 on the top. So that's why you have to divide by 2. Again, this same reason. Okay. Right. Then you will see that all those terms in the middle cancel out. Okay. So you will get 1/3 minus 100. Then that'll be 300. 100 minus 3 is 97. So 97 over 600. Okay. So a long time ago, we already know how to find the sum, right? Yeah, that has to be, I begin with m plus m plus 1 all the way to n, okay? So for example, such as s is going to be 7 plus 8 plus 9 plus 10 and here 97. All right. Now, how do you add them together? Do you still remember how to do this problem?
No. Where's that?
Do you remember? Okay.
压到100，这不就是那道题吗？这个 n 对啊，相当于那什么 n 的代表就一直。
Right. So the idea is that you need to count how many terms you have here. Okay, so you reverse the order 97, 96, okay, and 95, 94, and all the way to 7. When you add them together, this side is 2, and this will be the first term and the last term, right? So 7 plus 97. But all of them will be the same number. They're all same number, okay? So will be 104. So, but the question is, how many terms do you have here, right? You have to multiply the number of terms, right? The number of terms here is going to be 91 terms. 97 minus 6, not 97 minus 7, okay? So this will be 7 plus 97 times 91. So the average value, the first term plus last term, divided by 2 and multiplied by number of terms, okay? Then you can simplify them to get answers. Now, yeah, in particular, right? In particular, it's 1 plus 2 plus 3 all the way to n. It's the sum, the first term plus last term divided by 2, and the times the number of terms, okay? We have other formulas. We are not able to quickly prove it, and those formulas are also useful. This is a 1 square plus 2 square plus 3 square all the way to n square. That's n times n plus 1 to n plus 1 over 6. Okay. All right. Yeah, you can check, whether this is a correct formula or not, right? Another formula is the cube. This will be n times n plus 1 divided by 2 squared. It's always a perfect square, in other words. All right, let's look at the following. Okay. All right, so this is how many terms do we have? 100 terms, all right? So what is the first symbol? This is 1 over 1 plus 1 over 1 plus 2 plus 1 over 1 plus 3 plus 4. There should be some trick here, right? So to do this problem, I just need the formula 1 plus 2 plus 3 all the way to k is k times k plus 1 over 2, right? And that's all we need, okay? So if k is 1, it's going to be 1 over 1 times 2 divided by 2. When k equals 2, when k equals 3. Okay, so the last term is 100 times 101 divided by 2. Right? Now don't multiply them out. You want to keep the same stuff. Then, so 2 is in the denominator. You can take 2 out. So you will get right. So you get all those terms now. And since they're already familiar, right, you can cancel them. Okay, you can cancel them. So you can write this was 1 over 1 minus 1 over 2, 1 over 2 minus 1 over 3, 1 over 3 minus 1 over 4, and 1 over 100 minus 101. Right, so all of them in the middle will be gone, so it's 1 minus 1, right? And then you will 1 over minus 100 divided by 101, so it's 200 divided by 101. Okay, slightly, it's close to 2. Right, my next problem, simplify 1 minus 1 over 4, 1 minus 1 over 9, 1 minus 1 over 16, and 1 minus 1 over 2,500. Yeah, you think about it in the cruise. It's a product, has so many terms. Right, I gave you half a minute to think about it. Right, definitely we have to cancel some terms, right? Otherwise it's otherwise you cannot compute. Right, most of the problem we have, right, we cancel lots of terms. All right, so observe that 4, 9, 16, those are also perfect squares, right? They're perfect squares. So 4 is 2 square, 9 is 3 square, 16 is going to be 4 square, and so on. 2,500 is 50 square, right? That's good. All right, so the expression is going to be 1 minus this 1 minus 3, 1 over 3 square. Okay. Then what? You still have to cancel sometimes, right? So I have no other choice. I have to combine each of them. All right. So now I still cannot cancel terms. Don't worry. Remember, when you see a square minus b square, 1 is a 1 square, okay? Then you should know how what the next step is, right? So a square minus b square equals a minus b, a plus b, okay? So this is a formula we can use. Okay. So I'm going to factor. And so 3 minus 1, 3 plus 1. 4 minus 1, 4 plus 1. And 50 minus 1, 50 plus 1. Here, develop 50 square. Okay. I think we're almost there. I think we can group this together. Okay, it's 1 times 2 times 3 all the way to 49. And then this group together. So it'll be 3 times 4 all the way to 51. Okay. And then you have a 2 square, 3 square, 4 square, all the way to 50 square. I think now you know how to answer, right? There are lots of terms in common. You have at least this part will be the same, right? You get 3 square, 4 square, 5 square, all the way to 49 square. Plus 2 times 3 square, 4 square, and 49 square, and 50, 51. All right, so you can cancel lots of terms. I think you can cancel this part with the bottom part, right? So you get 2 times 50 and 51, and 2 square, and 50 square. It's 51 over 100. Wow. You see, when eventually cancel, right? Many problems, especially if you have a long sequence of terms, you add them together. And you should try to cancel terms. Otherwise, you're not able to evaluate them. So one by one, you cannot do that. Okay. All right, so let's go back to do a little bit easy problem. Okay, let's simplify. Let's simplify this. All right, please do it. All right, any ideas? Can you give answers? Okay, so just simplify it. And 3 plus 4 is just 11 over 4, right? 13, nothing wrong with that. Okay, then 4 over 13, right? Then you will get 26 plus 4 over 13. So 1 plus 13 over 30. Right, 30 plus 13 is 43. Right. Yeah, simplify. Let's do a quick review. Simplify. Yeah, simplify this. Yeah. 2021 factorial minus 2020 factorial. Divide by 2021 factorial plus 2020 factorial. All right. So common fact, take it out, right? 2021 is going to be 2020 factorial times 2021. Okay, so 2020, this is a common fact, and cancel it out. And then 2021 minus 1, 2021 plus 1. So the answer will be 2020 over 2022. Okay, so this is the number. And you can simplify a little bit. Divide by 2. Divide by 2, then you will get right. So finally, let's take a look at this next part. And here 100 factorial plus 99 factorial, 100 factorial minus 99 factorial. And then I have a 98 factorial plus 97 factorial. and keep it going. 4 factorial plus 2 plus 3 factorial, 4 factorial minus 3 factorial. And here 2 factorial plus 1 factorial, 2 factorial minus 1 factorial. Right. So remember, you should be able to cancel lots of terms. Okay. Yeah, trying to cancel terms. Can you do that? Definitely, right? They should be canceled out. Otherwise, how can this is so many products? Nobody can answer? This is a, yeah, this is a 5th grade math problem. Okay, I was told. But anyway, this is was yeah. Today we don't talk about X, Y, Z variables. Okay, we only focus on numbers. There's some tricks we have to learn. Okay, so remember, 100 factorial can be written to 99 factorial. So when you take this out, it'll be 3. Okay, and here 97 factorial. Then that would be 3 again, right? And so on. 3 factorial times 3. No. Hold on. I'm making this. Okay, then don't skip steps, right? It's easy to skip steps. If we skip steps, then you will make mistakes. Okay, and here 97 factorial is 98 plus 97 factorial. Okay, so keep it going. Yeah, let me try another line here. Here will be 3 factorial times 4 plus 1 plus 3 factorial. And okay. Similarly, the numerator, the denominator is subtraction. The denominator is 99 factorial, 100 minus 99 factorial, 97 factorial, 98 minus 97 factorial, and keep it going. So you do have a common fact, 99, 97 factorial, and then together with this will be canceled out. So you have a 101, 99, and so on. It's 5 and 3. Here, 100 minus 1 is 99. Right? Then 97 minus 1 is 97. 98 minus 97. And the last one here is 2 minus 1, right? And here 3 factorial, 4 minus 3 factorial. So what you get here, last part is going to be 4, it's a 3 in this one. Okay? So you can simplify, right? You will see that all of them are gone, just one away. Okay, so one way is answer. Okay, so don't be scared, just try to cancel some terms. Find a way to cancel terms, then you solve the problem. Okay, yeah, lots of tricky here. I discussed so many different type of problems. And next class, we're going to focus on algebra, okay? Algebra linear equations, system linear equations, and how to solve them, how to apply them to solve story problem.